Good day once again, ladies and gentlemen, and we meet again. And of course, we are still continuing on logs. So if you haven't subscribed, please just make sure that you're part of the family. And of course, you can always get in touch with us. Our email address is info@mlungisinkosi.co.za. Right, so we're looking at log equations today. Of course, you would have, watched the other two videos on logs, and I'm assuming that by watching this one, you've already done your due diligence on that in that regard. Right, so let me start with a few rules that we just need to be mindful of, right? When do we actually use log equations, right? And remember, once we've got an equation, we have an equal sign, right? So the first one is supposing that we've got, let's say, a log or rather an exponential expression, right? Let's just say for argument's sake, you've got 7 exponent x, which is equal to 5, right? So in this case, we cannot express the basis in this case as, to be the same in this particular instance. So there's no way that I can get base 7 and 5 to be similar bases. Right, so what do? We then introduce logs and we say, well, log 7 exponent x is equal to log of 5. So we introduce logs on both sides and just simply use our log rules. So we know this one jumps down, right? So in this case, this will be x log of 7. Okay, which is equal to log of 5. And so we can divide on both sides and say log 7 divide by log 7. And that is how we will solve for x in this particular instance. And so this will be equal to log 5 over log 7. And all you simply do is just put that in your calculator, log 5. I'm going to do that. Log 5 divided by the log of 7. Okay, and that will be our final answer, 0.83, right? To rounded off to 2 decimal places, right? So that's the first instance. So whenever we've got exponents, in this case, that have bases that cannot be the same, we introduce logs, right? But we also do have instances whereby we are given log expressions, and I'm going to talk about those instances just now, right? Now, let's suppose that you've got, let's say, log of, let's say, 2x plus 3, right? Which is equal to, let's just say, for argument's sake, 1, okay? Right, now, in this case, in fact, let me just make this a little bit simpler so that we would be able to understand. So let's say we've got the log of x, which is equal to 3, right? Now, please, I want you to listen carefully. So in this case, whatever the base is here, of course, I'm using base 10. When I want to solve for x, right, what I will do in this case, all I simply do is that the index here becomes obviously my answer there. So x will be equal to, now the base of my log becomes the base of the exponent, okay? So that becomes x is equal to 10. Now this answer becomes the exponent over here, right? So I want you to remember this, right? That there it is, your index there becomes the answer. And the base becomes the base of the exponent, and that becomes your index in that case. And so that is x is equal to 10 to the exponent 3, right? So whenever you are doing that with logs, you always keep that in mind. I mean, for those of you who've done, who've worked rather with pH in physics, you know that pH is minus the log of your hydronium ion concentration, right? So in order for us in this case to find out what this is, the concentration of our H3O plus, all we simply do is H3O plus right? So this is like our x over there, right? Which will be equal to, in this case, you can multiply both sides by the negative, so the negative goes there, and this one is now positive. So this will be 10, that's our base, right, to the minus pH, right? So that there becomes your exponent. So what I'm simply trying to say to you is that when you are solving for log equations, in this case, we must remember this rule. Of course, all the other rules still hold in this case. All right, we just need to remember that when we've got the log of, okay, I remember I've shown you this before, right? If I've got the log of b exponent a, in this case, that, or rather base a, rather, this becomes the log. You can express this as the log of any other base, right, of b divided by the log of that particular base divided by a. So this index here and this base over there, I can now introduce a different base, right? And that index becomes, in this case, the index there, and the base becomes the index of the denominator. Right, so in this case, we just need to keep that in mind, right? So, as we rightfully said, we can use that in log expressions. Just something else that I needed to remind you of, ladies and gents. So if I've got the log of b base a, remember, this is the same as 1 over the log of, I can swap the base and the index around, of b, in this case the log of a base b, right? So keep that in mind as well, and this is something that we also need to be mindful of. Now let's go to that example that I wanted to show you earlier on, right? So if I take the log of 2x plus 3, which is equal to 1, right? Now how do I solve this? In this case, what I will need to do is introduce logs on both sides, or I'd need to have logs on both sides. Now remember, this would be base 10, right? So that means 2x plus 3 in this case would be equal to, right? You can put this as 10, right? And that becomes your exponent. So that's 10 to the power 1. So this would be 2x plus 3 is equal to 10, right? And so 2x is equal to 7. And so in this case, you can divide both sides by 2. And so x would be equal to 7 over 2, right? So another way of looking at this is that I can now look at it this way. Now, please, I want you to follow me in this. So log of 2x plus 3 would be equal to, would be equal to 1. What I can do is make sure that I have logs on both sides with the same base. Now, please, I want you to listen carefully. So what I do is, how can I express 1 as a log? You remember, this is equal to log, right? Now, if this is base 10, that would be 10 over there. So in this case, whatever base I use there, I would need to use the same index, right? So in this case, right, once the log, you've got logs with the same base on the on either side, then it means that I can drop the logs. So 2x plus 3 would be equal to 10. I think this would be an easier way of solving log expressions, right? And of course, you can continue with that. Right, now let me show you this very same example. So in this case, let's say I've got log base 3, right, of, let's say, let's just take any other example, let's say 4x, right, which is equal to 2 in this case. Now, how can I write 2 as a log? In this case, this would be log of base 3 of 4x, which is equal to, now think about it. Remember that 2, right, this is 2 times 1. Now, how can I write that as 1? So I need to maintain the similar base. So log 3 and 3 there, log base 3, but in this case, base 3 of 3, right? So notice this becomes 1, so I have not changed anything, right? Now, I want you to realize this. So I need to make sure that I only have logs on either side before I can drop them down. So this would be log base 3 of 4x, right? This would be equal to log of base 3 of 3 squared, right? Remember, this goes and becomes my exponent. So now I've got bases, logs of the same base on either side. So what does that mean? It means that I can now drop the logs. So 4x would be equal to 3 squared, which is 9. And of course, we can work that out going all the way. So that would be 9 over 4 as our final answer, right? So what I want us to do is to take some examples that we will use on logs. And I'm going to just toggle between the two laws, or rather the ways of expressing it, and find an answer. All right, so let's look at the exercises that follow. And I'm sure you're going to find these very interesting. So just stay with me at the moment. Right, so let's start with the very first one. We're given log. Okay, so let me just get these out of the way. So we're given there, we've got the log of, which is base 10 of x minus 1 plus the log of x plus 2, and this is equal to 1. Right, now ladies and gents, I want you to please follow me in what I'm going to do. Right, so again, every rule that we've learned on logs still remains, right? So you remember we said when we are adding logs with the same base, in this case, it means that we can actually multiply the indices, right? So in this case, I'm going to have log of x minus 1. So that's x minus 1, x plus 2, right? And in this case, this is equal to, now remember I've got a 1 on the other side, so to change it to a log with the same base, that would be log of 10, right? So I'm already doing that in the first instance, right? So that we can be able to solve. Now in this case, what does it mean? It means that because both of them have got the same base, we can drop down the log. So in this case, x minus 1 into x plus 2 will give us 10. Do you see why factorization was such an important thing for us to learn? Right, so remember, because it's not 0, so we would need to actually, in this case, multiply so that we make this a quadratic function in standard form. So this will give us x squared, right? X times x is x squared. We've got 2x, right? Plus 2x minus x, so that will give me plus x, right? And this would be negative 1 times 2, which would be minus 2, okay? Taking the 10 this side would be minus 10, which is equal to 0. Of course, you can work this out in your own pace, right? So I'm just, my interest is in us finding the answer, right? So that's going to be x squared plus x, okay, minus 2 minus 10, that would be negative 12. This is equal to 0. Okay, now we can factorize because we've got 0 on the other side. So we've got that. So we've got x and x over there, factors of 12, such that when we subtract them, give us 1. That's going to be 4 and 3. And of course, it means that this will be positive and that negative, because if you haven't watched our video on factorization, please, this would be a good time. So x is equal to negative 4, or x is equal to 3. Now, very importantly, ladies and gents, once you've gotten your answer, it doesn't mean that both solutions are actually applicable to your equation. Why am I saying that? So we need to go and test this, because remember what's illegal. We cannot find the log of a negative number, right? So we can't have log of minus 3, for instance. That is undefined, right? So if we get ourselves that means that solution is not applicable in this particular instance. Now let's go back, right? Look at that. If I go and substitute minus 4 into that original equation over there, right? So I end up with log of, now notice I've got x minus 1. So that becomes negative 4, negative 1. Already, do you see what this does? It makes this the log of negative 5, right? So without even checking for the other solutions, I already know this would be illegal here. So what does that mean about this solution for x minus 4? It means this is not applicable. So this is not a solution. Now let's go and check x is equal to 3, right? If I substitute there, 3 minus 1, 3 plus 2. So in both instances, 3 minus 1 would give me 2. 3 plus 2 will give me 5. So in both instances, I'll get a positive number. So it means that is a solution. So in this case, I know that it means therefore x is equal to 3. So this one would actually be an applicable solution. So please remember to go and check for your solution. All right. Now let's go for the next one very quickly. So log base 6, x plus 3, x minus 2. Right, so for second one, okay, so we've got log base 6, x plus 3, right, plus log base 6 of x minus 2, okay, I believe also equal to 1. Okay, let's just verify that. Okay, right. So in this case, now again, we can do the same thing, right? Log x plus 3, that would be x minus 2, okay, using our first rule, right? So that would be equal to log, now note, our base is 6. I'm going to change this to base 6, but that means that is log 6 base 6, okay? So what do? The same thing that we did. So we can drop down the logs because we've got similar bases on either side, right? So that means x plus 3, x minus 2 will be equal to 6. So I've got x squared, I've got negative 2x plus 3x. That will give me plus x, negative 6, which is equal to 6. Again, which means we've got x squared plus x minus 12, and this is equal to 0. So we've got, again, x and x there. We've got 4 and 3. So that means that this will be positive, that will be negative. So x is equal to minus 4, or x is equal to 3, right? So again, we can go back and check, right? We've got negative 4. Let's see. If I put negative 4 there, it becomes negative 4 plus 3. So therefore, it becomes negative 1. So in this case, negative 4 would not be applicable for this solution here. But similarly there, you've got negative 4 and negative 2. That gives you minus 6. So in this case, it would not be applicable. So this is not a solution. And by the way, it doesn't mean that every time you've got a negative answer, it would not be applicable, right? You must just go and test it into your solution. Right, and x is equal to 3. So if I say 3 there, I substitute. So that will be 3 plus 3, which is 6. It would be 3 minus 2, which is 1. So in that case, which would be applicable, right? So this would be a solution. Right, so swiftly moving along to the next one. Right, so we've got, that's log of base 3 of x, right, minus 2 log of x of 3, rather base x, which is equal to 1. Now, ladies and gents, I'm going to apply the rule here where we say, well, look, we remember that the log of a of b, base a, is the same as 1 over the log of a with a base of b. So if I want to swap around those two, all I need to do is invert that log, right? So in this case, I want you to please note, so I've got the log of base 3 of x minus, in this case, how can I change this? This would be 2 over, so I make that, so that would be the same as saying 2 right, multiplied by 1 over log of base 3 of x, right? And this is equal to 1. Now, ladies and gents, what can actually help you here is, just remember when we use the k method substitution, we can do that here, right? So I can say let log of base 3 of x equal to k, right? So let me do that quickly. So that means I would have, in this case, k, right? So that would represent k minus 2 over k, right? Which is that guy there, which is equal to 1. So multiply everything by k, so that would becomes k squared minus 2 equal to k. So let's try and solve that. So that's k squared minus k minus 2, which is equal to 0. And so if we factorize, and remember we are meant to solve for x and not k, right? So that means we've got k minus 2, that's k plus 1 in this case, which is equal to 0. So that means k is equal to 2 or k is equal to minus 1. Now let's take back what we have. So remember that log of x base 3 is k. So that means log of x base 3 is equal to 2, or log of x base 3 is equal to negative 1, right? Now again, there is no way that you can have a log of a negative number, isn't it? Okay. Oh, actually, no, I'm incorrect. So if our index was negative, so we can actually apply that. All right. So let's look for it there. So what are we going to do? You can introduce logs on both sides, but I'm just going to use that method there. So x would be equal to 3, right? So the base becomes the base there, squared, right? If you wanted to, you could have actually used the similar method that we've kept using. Log x is equal to, right? So in this case, this would be 2, the log of 3 base 3, right? So in this case, what you would have there is that because before we drop that down, so that means log of base 3 of x, okay, is equal to log base 3 of 3 squared, right? So you can actually use that, and then you can drop down the logs, and so x is equal to 3 squared, right? Please keep that in mind. In this case, on the other side, I have x is equal to, remember the base becomes the base here, and of course the answer becomes the index, right? So it means that x is equal to 3 squared, right, which is 9, or x is equal to 1 over 3. Both solutions are positive, so which means that we can apply them in our solution. So they're both applicable, right? All right, so let's go on to the next one very swiftly, right? So on the next one, you've got 2 log a, or rather 9. So that's a 9 there. Okay, so 2 log x base 9 plus 2 log 9 base x. Okay, so let's go on to the fourth one, and I'm sure that you've got it by now. So that we've got 2 log of x with a base of 9, right, plus 2 log of 9 base x, and we said this is equal to 5. Now once again, ladies and gents, I'm going to apply the very same principle, right? So we've got 2 log of 9, or rather of x base 9, plus, so on this one, I'm going to say this is the same as 2 over the log of, again, we've got, 9, base 9 of x, this is equal to 5. So I'm going to again allow that we say let the log of x with a base of 9 be equal to k. So in this case, I'm going to multiply. Okay, so that becomes 2k plus 2 over k, which is equal to 5. So multiply everything by the lowest common denominator, which is k, right? 2k times k, that will be 2k squared, plus 2 over k times k will give me 2, which is equal to 5k, right? So that's 2k squared minus 5k plus 2, which is equal to 0. Right, so again, we're going to try, and so that's going to be 2k, and if we use that there, right, so this is going to be 2 here and 1 there, right? So both our brackets should be negative, so that's negative and negative. So in this case, we've got k is equal to 1 over 2, or k is equal to 2. So let's apply that once again. So we know that k represents the log of x base 9, which is equal to 1 over 2, or the log of x base 9 is equal to 2. All right, so again, our solution x is equal to the base becomes the base there, and the solution becomes the index, right? Which is equal to, again, or, I should actually write or there, x is equal to, again, my base there, and that becomes my index. Okay, right, so in this case, x, right, this is the same as the square root of 9, so x is equal to 3, right? Or, now remember, if I take the square root, that would be plus or minus, okay? But in this case, that cannot, we cannot have a negative answer there, so x would just be equal to 3, or x would be equal to 9 squared. In this case, remember 9 squared is 81. Okay, so those are our two solutions over there. Right, I hope that you are able to grasp this, ladies and gents, that I'm not rushing you into it. And then the final question, there we have it there. Right, so we've got log of base 9. Okay, so let's write it down over there. Right, please just try it out on your own and see how far you get with it. Plus 1 over 2 is equal to the log of base 3 of x. Now, we're going to do quite a number of gymnastics there, because, can you see, we don't have bases that are the same, but we need to get them to be the same, right? So what I'm going to do is, right, so keep in mind that when we say the log of, right, I'm going to just change these around a bit, okay? So I'm going to have the log of, now you remember, so I said we can write this as, okay, the log of, I'm going to have log of x over, rather, let's write it properly. So I'm going to have the log of x, right, with 9 there, right, plus 1 over 2, and log of x, 3 base x rather, or x base 3, this would be log of x, right, with a 3. In fact, I'm just dragging this right now, okay? So now, I need to make sure that the bases are the same over here. And how do I do that, right? Now remember, so I'm going to just simply swap it around, okay? So I'm going to say this is the same as 1 over, okay, the log of base x right, to the 9 plus 1 over 2. Now remember, I've changed nothing there, right, which is equal to, again, this is going to be 1 over the log of base x to the 3. Can you see now my bases are the same, right? So what I can actually do, remember, I can say, well, look, this is the same as 3, 9 is 3 squared, right? 3 squared. So therefore, what does this become? It becomes 2 log 3, right? So I can say again, let log of base x to 3 equal to k. So let's write that down nicely. So this would be 1 over 2k, right? Plus 1 over 2, okay, which is equal to 1 over k, right? So we can multiply by the LCD, and our LCD would be 2k. So if I say, okay, multiply everything by 2k, right? You do the same on the left as well as on the right. So I've got 2k times 1 over 2k, that will give me 1, plus 2k times 1 over 2 there, that would give me k, all right? And that would be 2k times 1 over k, that would give me 2, right? I hope you can see that well there, right? So I multiplied this there, I multiplied this there, right? That gave me 1, that gave me k, right? Because the 2's would cancel, and here the k's would cancel, and I'm left with 2. So 1 plus k would give me 2, so it means that k would be equal to, if I take the 1 to the other side, 2 minus 1, that would give me 1. Okay, right, so, but remember, we did say that k represents log with a base of x to the 3, right? So this is equal to 1. I'm sure you remember this, ladies and gents, that we said, okay, so what you can do here, in fact, our answer is really quite simple, because we said, okay, so this becomes, in this case, the solution, right? And you say, well, this is going to be 1 to the x, okay? All right, so we said this becomes the index, or if you want to, in fact, let me just make it simpler for you. So we can say, well, this is the log of x to the 3. This is the same as saying this is the log of base x to the x, right? I think it makes it simpler when we look at it this way, right? So what do we note? We can drop down the logs because our bases are the same. And so what does it mean? It means that x would be equal to 3, right? And so this is our solution, and I hope that you are able to really follow and you enjoyed these. So the only way that you can get more fluent in this is obviously if we keep practicing. I think what I'm going to do in our next video, we're going to make sure that we have some more of these so that we can solve for them. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.